We got a new subscription box here from CyberCityCircuits. Seems like these are the only videos I've been making here lately. I've got some new material in the works, so if you get bored of this, hopefully I'll have something that interests people. But I like putting these little kits together. It reminds me back when I was a kid. See what we have this month. We have their business card like always. And we have some information on the infamous 555 timer, probably one of the greatest ICs ever invented. Anyone that's ever, if you're getting introduced to electronics, this is definitely one of the ICs. You need to buy a bunch of them. They're really cheap. I think they're considered to be obsolete now, but you can do so much stuff. It's a great way to teach you about electronics. It's an incredibly versatile chip. And we have a thank you card from them. And a CyberCityCircuits sticker. And the paperwork. And it says it's a red and blue LED strobe kit with 2 555 timers. This is going to be interesting. Alright, let's take a look. Yeah, let me move the Dave Jones out of the way. And pour all the contents out here. And there's our 2 555 timers here. We got a capacitor. It's an electrolytic capacitor. We got a little ceramic capacitor. And we got some couple of resistors. And look like red and blue LEDs. Let's take a look at this circuit board. And like always, these circuit boards are high quality. I don't know if they manufacture them themselves or they send them out, but it's a really good job. I mean, it's quality. Okay, let's start putting this guy together. The first thing we're going to do is check all our components to see if they're here. We should have 2 of the 555 timers, which we do. 2 of the 8-pin sockets for the timers, which we have right here. Which I'm probably not going to use. I'm just going to solder the... Yeah, I'm going to just solder the 555 timer straight in the circuit board because I need those sockets. That came in handy. Okay, we got 2 470 ohm resistors. I'll have to put those on the multimeter. My eyes are not what they used to be, and I don't know if anybody can see that, but I'm colorblind. To me, this resistor looks to be gray, orange, and gold. And it says we have a 0.1 microfarad capacitor. This is going to be the ceramic capacitor. 5 red LEDs, 5 blue LEDs, which we have. battery harness, 9-volt battery. I like their little description here. It's a battery. PCB, printed circuit board. We have all that. And we have a little electrolytic capacitor here. It is a 2.2 microfarad 50 volt. I don't see this on the parts list. Let me look at the circuit board to see if it's on the legend on the circuit board. Yes, we have it right here. There, that's the spot. That is, you can focus. That's for the electrolytic capacitor. So, and yes, they have it marked for the polarity on it. Okay, so we're good to go. All right, so let's start putting this guy together. Okay, let's clear some of this mess out. And get the multimeter here and check some resistors. All right, good rule of thumb. Do your shortest, or the actual components that sit closest to the board first, so you don't run into the problem where they get into the way. All right, we got our 268Ks right here. That looks like ass. We might have to put some flux on this. Yeah, I think we're going to have to flux it. Okay, now I got the flux out. Not trim the extra wire, the leads out. And I'm going to use some different solder also. I had this little bit right here left. I think it's probably some of that BS lead free stuff. Alright, we're going to put our other two resistors in, our 470 ohms. And put a little bit of flux on it. Alright, let's try this again. You know, I took those soldering classes last week and I thought I was ready to go soldering. Apparently I need more classes. Just kidding. I've actually been soldering since the 80s, believe it or not. That's just nasty. Alright. Let's see what we have next. I think we're going to put our ceramic capacitor in. Right here, this thing is not polarized. You can put it in any way you want to. So we're going to bend our leads together. Like the holes are, the spacing is a little bit off, but it's okay. We're going to just force it in here. If you ever force one, don't try to put too much tension. You don't want to break the leads off. And it's alright if it sticks up off the board just a little bit. Well, wow, that's really tight, but we're going to make it work. Get a little bit of flux on this guy. Or a whole lot of flux. Okay, the next thing we're going to do, we're going to put in our IC circuits. And they're real simple. You see you have a little notch here. And you have a little notch up on top of your IC circuit. You just line those up. Sometimes you see right here you have this dot. And you'll have a dot on your IC chip right here. Just line them up. And we're going to solder these straight into the board because I'm going to save those sockets because I need them for a different project. And these being 555 timers, I got tons of them. It looks like CyberCityCircuits actually sent this in the real anti-static foam versus the styrofoam that you get a lot of them from the cheap Chinese companies. Alright, I'm doing that off camera, so and try not to bend the pins up like I'm doing. You can usually roll these on the table and they'll roll and fit right in, but my method of brute force works sometimes too. Make sure we have everything in the right spots. And I always like tacking the corners. And we come back and Alright, now we have our ICs in, and we're going to go with our electrolytic capacitor. This thing is polarized, so you have your stripe here, that's going to be your negative. You can also tell you have your two leads coming out. Your long lead is your anode, your short lead is your cathode. Anode's always positive, cathode is always negative. Remember, A comes first, so your flow of electrons is actually really backwards, but the way they teach you the flow of electrons is going to go through the positive and out the negative. So remember, A comes before C, so the A is the positive side, the longer leads. And we're going to look right here, and there's a little bitty plus here, and then we got our stripe right here. That's going to denote, that's going to let us know that that is for the negative. So we'll slide that guy in there like this. Clip our leads off. Alright, now we got our LEDs. If you notice on your circuit here, we have red LEDs and blue LEDs. Depends on how these are ran in the circuit, but you can't switch them around because they have a different forward voltage drop, and that'll cause your circuit to mess up. So what I'm going to do is stick all the blue ones in, and we'll solder those in place, and I'll come back and do the red ones. If you look on your LED here, you have your long side, that is your anode, and then your short side here, that is your cathode, so your positive and your negative. And on your LED right on the very edge of it, a lot of them, they have an actual flat surface to let you know that is the actual negative side of it. And if you look on your screen print right here on the legend, I don't know if that's screen print or not, I can't tell, but that'll let you know on your legend which side is negative and which side is positive. So just match up the flat side of your LED, and we're going to stick the blue ones in, and then I'll come back by and stick the red ones in. Okay, so now we got the LEDs soldered in. Now we're going to solder in our battery connector. And we have the positive here. And then the negative. Second verse worse as the first. Alright, let's shoot some juice in this guy and see what we get. Alright, let's plug it in. Oh, we have flashing lights. It's the Popo, y'all. I just programmed a simple siren circuit with the Arduino to go along with it. And there you have it. It's actually a really neat kit, especially for people starting out and want to learn about the 555 circuit. You can go online and just Google 555. I mean, there's tons and tons of information out about it. There are tons of little simple projects you can do on the breadboard, teach you about it. Let me cut this off. This is annoying. But yeah, like I said, another good quality kit from CyberCityCircuits. Their monthly subscription box, $12. You can't beat it. It goes to a good cause. So, hope y'all enjoyed this month's kit. I did. Alright folks, before I could get my video uploaded, I was on YouTube and noticed that one of my favorite YouTubers that I try to watch all his videos is Paul from LearnElectronics. And he was doing the same kit, and Paul was having some trouble getting the LEDs to light up. And I'm going to explain to y'all the problem that Paul was having and why it was so. Me and John Luke Gorbachev here. Alright, first thing you have to remember is even though these are lights, before they're lights, they're actually diodes, and they have forward drop, but they have forward voltage drop, and they're different depending on the actual color of the LED. So if you're running them in series and in parallel like this circuit is, it even makes them a little more difficult. And what Paul did is, no knock on Paul. Paul probably knows way more about electronics than I do. I'm not an electrical engineer or anything. I had some schooling, some education on electronics a long time ago. And my specialty is actually in the circuit board, not so much the components, but actual circuit board and circuit board designs. But I do know a little bit about LEDs. I think where Paul went wrong is, he does this stuff so much that you just kind of assume where everything's going to go. And the problem that messed Paul up is these two LEDs on the sides here. You have a red one here and a blue one here. You can't mix those up, and you can't mix these up, because on the LEDs, before they are an actual light, you got to remember they are a diode, and they work like a diode, and they actually they all have different forward voltage drops. Each individual color is made of different material, and it causes them to have different forward voltage drop. So when he swapped the LEDs around, I guess he assumed that this should have been all red on this side and all blue on this side, and that's where the mistake happened. Once he swapped them around, what happens is the blues actually take more voltage than the red ones do. But the red ones, as they start with their voltage, it's a little bit past 1 volt, I think. I'm probably going to get a chart to show everybody. They start sucking the current up before the blue LEDs can have enough voltage to get current going to them. So what they're doing is the red LEDs are actually stealing all the current away from the blue, so that if you swap them around, there will not be enough current to actually drive the blue LEDs. And I'm going to show you on the breadboard exactly what's happening, what's going on, so maybe you can understand a little bit better. Okay, what I have here is 4 blue LEDs, and I'm going to use this coin cell here, and we're going to light them up. Okay, see how all 4 blue are lit up? All right, and we're going to swap one of them out with a red LED, and this guy right here is pretty much going to hog all of the current. See, the blue ones don't cut on anymore. We take it out, so you see what's happening. All right, and then we can change this around. Let's put four red ones in. Alright, now we're going to put a blue one in. Nothing. All right, now I'll show you on a graph and show you exactly what's going on. All right, this down here is your forward voltage, and this is your forward current. Okay, if you look at the red LED right here, all right, this thing really starts lighting it up after probably about 1.5 volts. And you can see the peak of it. It starts drawing current really quick, especially as it gets around, you know, this is 2 volts. At 2.5 volts, I mean, this thing is drawing tons of current. So when the red one's drawing a lot of current, it's not leaving enough for the blue LED to actually even cut on. It's actually sucking all the current up. As you can see right here, where the blue LED is not really going to start to illuminate until you get about, I don't know, almost 2.5 volts or so, and then as it gets near 3, and it don't really start getting to the peak limit up here until about 3.5 volts. So that's what's going on. I hope you understand the graph and understand how forward voltage works. So it pretty much the red LEDs is hogging all the juice. And I'm pretty sure, you know, if Paul would have looked down and looked at the schematics and just sat down with the board and looked over, he would have definitely understood what was going on. And if people were leaving some nasty comments about all of that, they don't really understand. We all put these kits together. We all run into little problems. Most of the time when you have a problem like that, you've probably put an LED in wrong, or you have a bad LED. These are real common things. So you go to the most likely causes. And like I said, and I bet you Paul probably didn't even look at the legend on the circuit board to see that those two were actually red and blue and they're swapped around. And if he would have, it would have fixed it to solve the whole problem. He probably, like I said, he probably didn't look at any schematics or even looked at the traces to see how it's all figured out. You know, all of us do it. We all make mistakes. But the big thing with LEDs is always remember that they are lights, but they are diodes first, and they all have a forward voltage drop, and they all draw current. And this is a good chart to go by if you want to start mixing LEDs up and trying to figure out, you know, how you need to set them up where you don't run into that issue.